Hi all, I wanted to do just a quick little video. I've had a few questions on 6.4. What do I expect you to be able to do and know from that section? I've got Jack, my little guy, here with me, so if you hear some crying or thumping around, that's what it is. So for 6.4, all I really expect you to be able to do is to take an equation, something like r equals 2 sine theta, create a little r theta table for that, or really theta r table, and then plot those points. Now to get the exact curve or the exact figure, I have no problem if you use your graphing calculators to help you with these. The most important thing is just being able to set up that theta r table, and that shouldn't be very hard because we've been finding those values for a while now. So let's take this example. I set up my theta and r, and remember when we tend to list, or when we list these points, we always write them in the format r comma theta. I'm going to list them backwards here because really the theta is inside the function. So let me take some values. We'll take 0, pi over 6, maybe I'll get a pi over 3, pi over 2, and I'll plug these in. So sine of 0 is equal to 0. Sine of pi over 6, we get 1/2, and then we multiply that by 2, we get 1. Sine of pi over 3 is root 3 over 2, times 2 is root 3. Sine of pi over 2, we'd get back to the 1 there, the whole 1, and then we multiply that by 2, so we get 2. So if I set up really I'm setting this up in polar form, so I'm looking at my polar axis. And we can see we're going to get a max distance of 2 away. So at 0, we have the point, put in green, 0 right here on the origin. At pi over 6, we have 1, so we're on that first curve. Pi over 3, we have root 3, so getting up to 2, but not quite there yet. And then finally, when we're at pi over 2, we have our whole 2. And then I know that sine, as I come back down through that second quadrant, I'm going to have the exact same value, so I'll have the root 3 at the 2 pi over 3, then I'll have 1 again when I get to the 5 pi over 6, just all those second quadrant values. And so now I'm going to do my best attempt to connect these. I do know they connect on a curve, and so what we should be seeing is that we get a circle. My drawing was perfect, this would be a circle. So again, that's all I'm expecting you to do in this section. Take something pretty basic, set up that theta r table, plug in those points, see what the graph looks like. I don't expect you to have the shapes memorized, don't expect you to know these tests of symmetry by heart. You can look those up in the book if I were to ask you something about those on the homework or on the lab. But the thing with those is they are inconclusive a lot of the time, so we have to look at the graph a lot of times to determine whether something has that symmetry.